Hi folks, and welcome back to the WTF and this magnificent display of panoramic adapters, including my homebrew one, which we're going to be talking about at the moment, and we've also got one down there which is the panoramic adapter from the KX3, and I've also got, if I can get it to work, there's one there which is my little SDR receiver, the Malachite, which we talked about quite a few videos ago. Anyway, I don't think my camera is going to tolerate not having any light for too long, so we better set things up and we'll have a quick chat before we show you some of this lovely kit. Right, I've got some panoramic adapters which I showed you a few minutes ago when we had all the lights off, and what I'm going to talk about is actually what a panoramic adapter is. Now, for some of you who might have sort of more modern rigs, such as the ICOM IC7300, or let's see, the Yaesu FTDX 101, you know, some of these modern rigs have a display in front with a waterfall, and they look very nice, and those are essentially what we call panoramic adapters. So a panoramic adapter, what does it actually do? So it takes, or it provides a visual representation of a certain area of the spectrum that you're listening to. Now, they obviously vary in terms of the amount or the sweep or the frequency extent to which they display at any one time, but the whole idea is that they can give you an idea of where stations are on either side of the frequency that you're actually tuned into, if that makes any sense. So that just gives you an idea, especially, you know, if you're doing a contest or if you're looking for DX, you can see on a waterfall exactly where those hidden stations might be, and I guess it gives you a bit of an example. We've got a number of pan adapters here. We're going from the very modern in design to the very ancient. This is actually a homebrew pan adapter that I made, and I'll be showing you that in a minute. So we've got something here which is obviously quite modern. This is the PX3 made by Ellicraft, which goes with the miniature or portable KX3 rig. So this is the PX3 panoramic adapter, which is the companion to the Ellicraft KX3, and this little module you simply plug into your transceiver and it gives you a panoramic display. It's like what I said before, it uses the IF of the receiver and analyzes that to give you a spectral display of the of an area of the band. So if let's just play around with this a minute. I think I can see some stations. These bright areas here, which you can see on the waterfall, represent stations, and you can see there's a pip. There was a station there, which I suspect is a CW station. If we can tune into that one, there we go. So this type of display really is very similar to my homebrew one, but obviously a little bit more complicated, a little bit more sophisticated. And most of you who have got modern rigs will be familiar with this type of display. You know, the IC7300, the FTDX 101, they've all got a waterfall display or panoramic pan adapter display. I think, and I generally think that, you know, because of the simplicity of the way these things are going, that they're coming out more and more. and you know, obviously this is quite a modern thing, and it's but it does exactly the same as this. So what all these pan adapters have in common, this one is slightly different. This is actually a receiver, but it has a sort of waterfall display and a panoramic display, so to speak. But what both of these have in common is that they tap into the IF of the receiver they're plugged into, and it's the IF, the intermediate frequency, that is analysed to give you a spectral display. A bit like a spectrum analyzer, but sort of much smaller bandwidth that it's actually examining. Now, panoramic adapters have been around for quite a long time, actually. I didn't realise this. I thought they were sort of a relatively modern invention. But we have the APA 10, for example, which is a very old panoramic adapter, which was used on aircraft during the Second World War. And the reason why they used these was basically to give a sort of visual representation of if there was any evidence of, you know, jamming or spurious enemy signals that might be trying to intercept or trying to block, you know, communications between Allied aircraft. And the APA-10 is quite a nice example of a sort of 1940s panoramic adapter. One of the slightly better well-known ones is the Panoramic PCA 2-T200, which this panoramic adapter here that I made is based on. And that was again designed in the 1940s, and was actually commercialized by Hallicrafters to produce the SP44. So, you know, obviously these things have been around, and I don't want to dwell too much on the sort of more modern ones, because I want to show you my homebrew thing and how it all works. I've been playing around with it, and if I just turn up the gain on this and I turn the dial, you can see it's working pretty well there. So unlike a waterfall, we've got a pip or a spike which indicates where our stations are. But we'll have a look at this in more detail. What I'm going to do is I'm going to show you this the homebrew version, and then we can have a look at the circuit and see how one of these panoramic adapters actually works. So this is my homebrew panoramic adapter, which is loosely based on the Panoramic PCA 2-T200, but there's all sorts of modifications. I've sort of robbed various ideas from a number of other panoramic adapters, namely the Heathkit HO13 and also the Hallicrafters SP44, which is actually pretty much identical to the panoramic design. Anyway, just to show you the front panel very quickly. So obviously we've got our CRT display here. We've got a number of controls here, which just going to whiz through. The center frequency, well, that's self-explanatory, so that adjusts the position of the pip on the screen. The sync here is basically adjusts the rate of the sawtooth generator going to the horizontal deflection plates. We've got a sweep width here, which obviously refers to the amount of frequency or spectrum that you're actually looking at, which can be varied from about, I would say in this, probably about 50 kilohertz down to just a few hertz. We've obviously got our gain here, and then we've got a number of other controls at the bottom here, which are sort of quite familiar. You know, if you've used an oscilloscope before, you'll recognise these things like X shift, Y shift, focus intensity, and our equalizer here on the end is basically sort of the gain coming out of the IF transformer. And then also at the end there's a sweep pad, which basically adjusts the. It's almost like a fine adjustment of the sweep width. Construction, very simple aluminium panel, which I've painted to go with all those other rigs I've got, which is turquoise. It's sort of like the same colour you have in Russian aircraft cockpits. I don't know, I quite like it. I quite like it, just a bit different from greys and blacks and all the rest of it. So top is a aluminium perforated sheet, and then the whole thing is based on a Hammond aluminium chassis, which are quite easy to get hold of from various sources online. So that's the outside of the pan adapter. What I'll do is you'll have to bear with me to unscrew some of these screws, which there are quite a lot of, and we'll take the lid off and the bottom. You can have a look inside. And I'm just going to whiz through everything here just to show you what's what. So this is obviously the CRT, and I think the CRT tube was a 3BP 31 or 32 made by Mullard. I did actually buy that new old stock, but they're quite plentiful. We've got a number of obviously the valves here. This design, which is, as I said, based on the Panoramic PCA2, uses a lot of these metal valves, 6SG7, 6AC7, etc, etc. These are obviously IF transformers, which came out of the junk box. Voltage regulator tube, the power transformer, that's also another power transformer to provide some of the voltages. This is our LT transformer, again providing some of the heater voltages. These two IF transformers here are our 262 kilohertz IF transformers. I had to buy these from the States, actually. Couldn't find these at all in the UK. Well, not on eBay anyway, so they had to come from the States, and there's another two metal tubes there, down there, and this shield is actually a piece of steel exhaust pipe, so it works quite well. And then down here is our coil and tune circuit for the oscillator. So let's quickly turn it over and have a look underneath. So just to whiz around the underneath, again, not going to spend too much time on it. It looks a bit of a rat's nest, actually, partly because I had to keep changing components to get the thing to work properly. I was sort of experimenting with different things, but you know, here we've got the power supply, standard bridge rectifier with some diodes. Moving along, just things of note. That's the that's actually a tune circuit for the IF of the Panoramic adapter, tuned to about 262 kilohertz. In it, the object of that is to try and basically short any spurious IF signals coming from the pan adapter to ground, so that it doesn't interfere with the input, because that's the main input there from your receiver that you're plugged into, that comes in that BNC socket there. What else? This is a little audio transformer which is for the sawtooth generator, and you can get those off RS. It's a simple one-to-one audio transformer, and the rest of it is, you know, pretty much standard, you know, octal valve bases, and the components all set out as per the circuit diagram. I've got a little tuning capacitor there, that's for the adjusting of the oscillator tune circuit. So this is the circuit that my Panoramic adapter is based on, which is the Panoramic PCA2-T200. I've made some modifications, and This will also explain how the actual panoramic adapter actually works. So if we look at the top left-hand corner, you can see the input to the pan adapter, which comes via a broadband IF transformer, 455 kilohertz, and the input is connected, as illustrated there, to the receiver converter plate or the mixer plate of your receiver. Now the standard recommendation for this, if you look at a lot of pan adapters, is that you use a 50k resistor and a capacitor and a short length of coax, which then goes into your input. Now the problem with this is that you tend to get high voltage on the output of the IF going into your pan adapter, and a useful little circuit you can use, which you can put into your old boat anchor receiver, is a little cathode follower, a triode cathode follower. And I got a circuit from a fellow YouTuber, Mr. Carlson's Lab, which some of you might be familiar with. He's done loads and loads of videos, lots of stuff on valve stuff, and he described his circuit, which works really well actually, which you can you can use on your boat anchor receiver to get rid of some of that high voltage. So the input then goes into a 6SG7, which is it's like a signal amplifier, amplifies that IF frequency, and then it goes into another IF transformer for 455 kilohertz, and then into the 6SA7, which is sometimes called a pentagrid converter, and we'll talk about that in a minute. So after that, the output of that, you've got your 226 cycles or kilohertz IF, which is then amplified by V3, and then you've got the output of that is then demodulated by the V46 SQ7, and then amplified, which provides a bit of audio output, which you can connect to the pair of headphones. But more importantly, that voltage is used as your vertical deflection, so that you can get your pips. So the way all this works is, the heart of this is the sawtooth and the oscillator valve. So the sawtooth generator is a double triode, and you've got a little transformer there, a little audio transformer, which is what I use, and the sweep frequency is essentially linked to the AC frequency of the valve filament, 6.3 volts. So your sweep frequency is approximately about half the mains frequency, and on my setup I can actually vary that frequency by my sync control. So the output of that sawtooth generator is then linked to your oscillator valve, which in this case is a 6AC7, and you'll notice there's a tuned circuit there, which outputs at about 681 kilohertz. Now, and using R12, C13 and R13, that little resistor capacitor network, it works as a sort of phasing network, so that when it's linked to the sweep voltage, you get a sort of a frequency modulated output from that oscillator. And the oscillator as well, the oscillator valve, the way it also works is that the frequency of that tuned circuit can be varied by varying the transconductance of that 6AC7. So ultimately what you get is a frequency modulated output from that oscillator, which is then being mixed by your 6SA7. So you're getting actually a sweep of the IF input, if that makes any sense, which is from about 350 to probably about 680 or 620 thereabouts, maybe a bit higher, kilohertz. So that what you're going to be, so the pan adapter is essentially sampling that frequency range to produce a pip if there's a signal there. It's a bit difficult to get your head round, but that's kind of like how it works. Now, if we look at that tune circuit of E5, I didn't actually do it like that. I did a slightly different way because I couldn't really get that to work as well as I wanted it to work. So what I did was I used a slight modification of that, which is based on the Heathkit HO13 panoramic adapter. And if you look at on this circuit diagram, if you look at V2A and V2B, you'll notice a bit of a similarity between the other circuit diagrams. So what you've got is again a similar sort of arrangement as to that 6 SA 6 SC AC 6 AC7 or 6 SA7, I can't remember which one it was, but anyway, what I've done here is you can see they've got a triode here, which is actually half of this valve. This is actually a pentode triode. So what they've got here is a varicap, which I used, and it works. I found it worked a lot better. So by varying the negative bias here, the negative voltage which comes from your HT from your tube, you can vary the center frequency, and also by varying the sweep voltage on R202 there on that pot, you can also vary the sweep width with that varicap diode. And I found this circuit worked a lot better. I got a bit more of a sweep, a better sweep frequency, or a better sweep width, I should say. And I found it just easy. The whole thing just seemed to work a lot better with the varicap than the other method. And the other advantage is that because the 6SA7 is a pentagrid converter. You don't need to use. You can do away with the original pentode on the panoramic circuit, and you can use the triode that's incorporated into the mixer. So it saves you a valve, I guess. So there we are. So that's more or less the circuit diagram. Let's take a look at the actual pan adapter. So anyway, I've got this tuned up on about 6 megs, because there's quite a few shortwave radio stations there, so we can have a quick look, peruse the band, so to speak, and I can demonstrate this to you. So I think I'll just see if we can just zoom in there on the scope. I hope you can see that. Sometimes the light can be a bit. Just get it in the center. There we go. So we've got a few stations there at the moment. We'll just turn up the gain, the AF gain. So each of those pips there represents a station. So if I could tune it, you can see it as I tune the receiver. You can see how the pips change. So obviously these are AM stations because it's on shortwave, and I've got the sweep turned up quite low actually, so it's actually sweeping sort of actually quite wide. But if I adjust the sweep slightly, you can see that you can see the modulation on either side of the carrier. So every little pip there is a carrier, it's a different station. So as I get it into the center frequency, you can see the station appear. Probably sweeping maybe about, not that much actually. I tried to get it wider with this pan adapter, but I'm probably only sweeping about maybe 10 kc, something like that. So it's not as wide as I would like. But you can certainly discern the different stations there. This is the good time to do a bit of shortwave listening, is in the middle of the night, because you tend to get lots of stations coming through.
$5 billion. whether it can be used to settle claims and families of the victims. The movement backed it to understand central bank through the country into an economic...
So we'll increase the sweep width a bit, or decrease it I should say.
Just
adjust it.
The International Labour Organization since about 900
You do have to fiddle with the controls slightly. Let's see what else we got. A couple of stations there. It sounds quite a religious type of station by the sound of it. But that's got a typical profile of an AM station there with a carrier, and you can see the mod on the sidebands adjacent to it. Well, I hope that sort of demonstrates the pan adapter. It demonstrates it quite well with AM. So we've got quite a nice load of shortwave stations there, and you can see it quite well. Okay, guys. Well, I hope you enjoyed that quick little demo of my homebrew pan adapter, and a little demo of pan adapters in general. Until we meet again. Thanks for watching, and don't forget to subscribe.